Well, I've got the diagram recorded in there that I went over to check for Monday.
Monday.
Thank you for asking.
Another
Yeah, it's a
shot.
lesson, but
Oh,
it did put up on it.
okay.
Okay, let me see who's not here, and then we're gonna get started. You're still writing things, but you remember anything and everything that you feel like this SOHCAHTOA could stand for? Or writing, I'm not sure, but I think I used this in this class, or anything and everything you come up with. Israel.
Here.
Felix.
Here.
Edith.
Here.
Eli.
Here.
Dahlia.
Here.
Stephanie.
Here.
Diego.
Here.
Jamie Lynn.
Here.
Sandy.
Here.
Brandon.
Here.
Brian. Juan Carlos.
Here.
Martin.
Here.
Nen. Kennedy.
Here.
Giselle.
Here.
Leo. Gustavo. Lirio.
Here.
Tyler.
Here.
Melanie.
Here.
Lazaro.
Here.
Jonathan.
Here.
Messiah.
Here.
Joanna. Kevin. Ehom. Let's see. Christina.
Here.
Johnny.
Here.
Luis. Cynthia.
Here.
Brian.
Here.
Lovely. Okay. Let's see what we came up with. So, today is a very exciting day because we are beginning Unit 4, which is one of my favorite units of the whole entire year, and it has to do with trigonometry, and there's this thing called the unit circle that we get to learn, which when I think of high school, when I took pre-cal, before I actually taught pre-cal and looked again closer at the curriculum, I feel like one of the things that would pop into my mind when I thought pre-cal was the unit circle. So it's very exciting. And if you ask anyone that took pre-cal last year, they would be like, oh yeah, the unit circle, and they'll be really excited about it, I'm sure, so ask your friends. And this unit will lay the foundation because we are going to continue to have a couple of other units that kind of have to do with trigonometry. We'll do the graphs of trig functions. We'll do these things called trig proofs. And so we want to make sure we feel really good about the foundation of trig stuff that we're starting with this this unit. If you take a look, you got a new tracker for participation. So today is raffle day, but also I'm going to be giving stamps for participation. Israel?
Yeah. Could I ask? Are we starting yet or not?
Oh, he's ready to participate. Hold on. Sorry, I made way too many announcements. So let me just sum up a few more things. So on your participation tracker, you will get stamps and tickets today, and please make sure you're using that. That tracker will go all the way through A3, which is pretty much all on this calendar. This calendar goes through the end of A3, which is right before we go off to winter break. Yeah. And so Unit 4 is the last unit you'll have left before Common Assessment and winter break. So we only have one more unit, which seems like maybe a longer amount of time compared to the last unit, but that's only because this unit is kind of spread out. For example, we have a week next week, but then we take a week for Thanksgiving break, right? Then we come back, we keep going with Unit 4, and then you'll notice throughout your calendar there's a few days that we're actually going to be using for SAT prep for some people that are taking it on December 2nd. And so we're going to have a few class days that we're going to kind of pause and do some SAT prep, so that's going to kind of slow us down a little bit with the unit. And so we won't be taking your unit exam until December 12th. And that leaves us 3 days, Wednesday, Thursday, Friday, the 13th, 14th, and 15th, to review for common assessments, because your common assessment week will start the beginning of the next week. Okay? And then you'll be off on winter break. So we've learned 3 out of the 4 units. We're really close. We got one more left, and it's a good one. Okay? So if you have any questions, let me know. You can see your assessments and all that stuff on your calendar. All right, so that brings us to... So Israel, now cue for hands.
Yeah.
Anything and everything you remember about SOHCAHTOA? What you got?
It deals with triangles.
I love that's a good starting point. So SOHCAHTOA has to do with triangles, specifically a special type of triangle.
Right triangle.
Right triangles, okay. Raise your hand if you have something else to add on. Martin. Oh, sorry.
For the first part, SOHCAHTOA is sine equals opposite over outside.
Okay, cool. He knows it has something to do with sine, and something about sine having to do with the opposite in the hypotenuse, which makes sense because we know it has to do with a triangle, a right triangle, which has a hypotenuse. Lazaro, what else?
Just use it behind the angle and sides of like side.
So technically it's actually relating the angle to the opposite and the hypotenuse. Okay, so it's sine of some angle, which I'm going to write theta, stands for an angle, equals the opposite over the hypotenuse for that first one. Melanie?
For cos is
Cos?
cosine,
This is co, you mean? Okay, stands for cosine.
Ah,
and but yeah, it's adjacent over the hypotenuse.
The A and the H stand for adjacent and hypotenuse. And the last Melanie, pick one more person out of the way.
Sammy.
You
Tangent is opposite over adjacent.
Okay, opposite over adjacent. So, if we have a right triangle, let's go ahead and draw a right triangle because I see some people that drew a picture, which I like pictures. If you have a right triangle, here's my little right angle right there, which is 90 degrees. If I have an angle, a lot of times we call angles by not like, you could use x and y in like any variable, but a lot of times we use Greek letters for angles versus sides. So you'll see theta and alpha and things like that inside your triangle. So this just means this is some angle that we don't know. If this is our angle, we've got three sides of our triangle that are related to that angle. We call them the opposite, the adjacent, and the hypotenuse. Okay, let's talk about where those are. If this is theta, picture yourself standing on top of theta. If you look opposite or across the triangle, this side would be your opposite side. Okay? Now if theta was up here, this would no longer be the opposite side, right? You would have to look across from that angle, okay? But from this angle, this would be the opposite. If you are standing there, like if I say, like right now, Messiah is adjacent to Luis, like they're like right next to each other, okay? So if this is theta, the adjacent side is literally touching theta. There's two sides touching, but one of them's special. We're going to call it the hypotenuse. So the adjacent is the other side that's touching, that's not the hypotenuse, okay? And then the hypotenuse, y'all have probably practiced, like you know the hypotenuse from other classes, but it's the longest side across from the 90-degree angle, where if you draw I literally can't draw. If you draw your right triangle like this, it's that like slanty side right there. But it could be like twisted any direction and it would still be your hypotenuse. Okay? Okay, so those are our sides. And we know sine, cosine, and tangent of that angle somehow have to do with those sides, with sine being opposite and hypotenuse, cosine being adjacent and hypotenuse, tangent being opposite and adjacent. Okay, interesting. So that's what we're going to be dealing with a little bit today. It's raffle day. So raffle day today is going to be rolling to win. Woohoo! So let's recap our prizes really quick before we get going. We did this, right? Rolling.
Yeah.
Who won last time? You got cookies?
Yeah,
For everyone? Y'all all got cookies?
Cereal dance.
Cereal dance. Nice. Earlier, Gennaro in 11th grade danced for us. It was nice. But you have a question? What's up? The rolling?
That's for salty.
Ooh, we're going to be doing Pythagorean theorem today a little bit, but just in one example.
Good job, Brian.
Okay, so if you roll today a 1, there will be one winner who will roll. Some of the prizes could benefit all of us. Some of them could just be for them. If you roll a 1, then you get a 10 on your set. So, most excited apparently y'all hate
Wait, question.
promises. Yes, clarifying question.
Is it on the problem set that we got this week, or the one we will be
On
getting
a
next week?
problem set
You didn't want it.
of your choice. So if you have started the other one and you're like, I don't want to use it on this one,
Yeah.
then you can save it. Or if you're like, well, I started this one, but I just want to make sure I get a 10, even if I missed stuff, you could, whatever. Okay, if you roll a 2, then you get a treat of your choice, candy, chips, whatever you want, I will bring to you. You get to make your order. If you get a 3, we all get cookies, yummy.
For the entire class?
If you roll, yeah, the whole class.
The whole class is a 10 in the front set.
Yeah, no,
She said yeah. She said yeah.
no.
Look We got it on video.
We got a video, yeah.
We got it.
And then I said no. Also on video. Okay.
Answer is yes.
4. A gold medal.
Gold?
I did. We had an award ceremony and we had a gold medal winner earlier. It was nice. And then you get to dance for us.
Oh, yeah.
Very nice, just like Lirio did. And last, punch bowls. Can't lose with 6. Makes people happy. Bringing joy to children. Okay. All right. So that's the end of class. We'll deal with that later. If you missed the memo, we did have a problem set this week. It's been a weird week because we've had a lot of tests and stuff. So make sure you didn't miss out on that. And if you need a copy, make sure you get one before we leave for the weekend. Okay, trig ratios. Let's talk about, one more time, what we just introduced with SOHCAHTOA. This box that's blank right there, you're going to use to record some more notes. We're going to go back through sine, cosine, and tangent, and then we're going to talk about 3 more trig functions that we might need to know. So let's draw another triangle. This time, maybe draw your triangle facing the other way. Maybe draw your triangle facing the other way and put theta up top so that we can talk about how we would label it if it was in another location. If our triangle looked like this, we want to label the opposite, the hypotenuse, and the adjacent. Raise your hand if you can tell me where the opposite would be for this triangle. The left, the right, or the bottom of our triangle. Where would be the opposite side, Ihong? The bottom. Opposite, if I look across the triangle, would now be down here. Adjacent, Diego? On the right side over here because it's next to it, but it's not our hypotenuse, which is going to be this side across from the 90-degree angle. Okay, if you have all 3 of those, we already said sine, cosine, and tangent are these 3. However, I want you to actually write out, we abbreviate it, sin of theta, but we say it not sin, we want to say it as sine. If we actually write the full word of it, it's sine, and then we just abbreviate it like that, and we know that's equal to the opposite over the hypotenuse, right? Okay? For the next one, we don't say cos, right? What do we say?
Cosine.
So this is actually cosine, so I want you to write it down so that you have the full version. And if you say cos, I will just be politely interrupting you and asking you to restate it because I want you to really practice saying that as cosine so that when we get to like college level math classes, we know how to say them correctly, okay? So sine, cosine. This next one is not tan. It doesn't have to do with your tan. It's tangent. So again, I want you to say when you see this, don't say tan of theta. I want you to say tangent of theta equals opposite over adjacent. Okay? Okay. 3 more for us to talk about. Those are the 3 we see a lot and that you've learned with SOHCAHTOA. But each of these actually has what we call a reciprocal function. So we can take them and we can flip them or find the reciprocal. And we have 3 other functions to describe that. Okay, so the one that goes with sine is what we call cosecant. Cosecant, and it is abbreviated CSC of theta. If you've seen that, that's how we say cosecant of theta. And it is the reciprocal, so instead of opposite over hypotenuse, we would have hypotenuse over, I can't write, opposite. Hypotenuse over opposite. Instead of opposite over hypotenuse. Okay, now you have to just know that these 2 go together. It's kind of the opposite of what you would think. This one starts with an S and this one starts with a C. Where for cosine, its partner is going to be secant. It's confusing, it starts with an S. And secant is abbreviated SEC, secant of theta. And so, Jonathan, if cosine is adjacent over hypotenuse, what is secant?
Hypotenuse over adjacent.
Right? hypotenuse over adjacent, the reciprocal. Okay? Last one. We've got tangent. The reciprocal function of tangent is what we call cotangent. Can't write tangential. There we go. Okay, and that one we write like this, and this one is probably the one that most people do not say right because it looks like cot, and people just like to say cot because I put my name and they thought it was funny. Last year they were like, cot. 45 degrees, and I was like, so I am not a trig function. This is cotangent of theta is equal to what over what? Adjacent over opposite. Flip that one, okay? Sine, cosecant, cosine, secant, tangent, cotangent. I think tangent and cotangent, people usually don't have any problem seeing that they go together. It's the other ones you got to remember. Sine is with cosecant. Cosine is with secant. Okay? Okay. So we should be able to find any of these 6 trig functions if I give you a triangle with its side length. So let's look at the one right below and see if we can find all 6 trig functions of theta in our picture right here. Take a look at your triangle. Brian, is it a right triangle? It is. I see the little 90 degrees there. And so we have our right angle, but then we also have theta over here. And so related to that theta, we should be able to identify the sides of our triangle as opposite or adjacent or this, that, or the other. So if this is theta, I'm going to call on a few people to tell me which side is which. Tyler, come to you first. If this is theta, which of these 3 would you say is the opposite?
Where 8 is.
8. 8 is going to be our opposite because it's across from theta. Our hypotenuse, Dahlia, which one's the hypotenuse? 17 is going to be our hypotenuse, and that leaves our adjacent to be 15. So I would start with these problems. It helps a lot, like mark up your paper, label all the sides so that then it's easy to do your SOHCAHTOA for whatever you want. Okay, we're going to do one, then y'all are going to do the rest of them. Sine, really quickly, to solve this, just to make sure we're all on the same page. Sine, I know it is opposite over hypotenuse, so I'm just looking at my triangle now. Opposite is 8, hypotenuse is 17, so sine of theta is equal to 8/17. That's my ratio, okay? Go ahead, I'm going to go pass out tickets now and stamps. You guys do all the rest of the other 5.
Who did I have here? Me. Who was in this?
OJ?
Anyone else?
No, last night.
Oh yeah. Cosine. Adjacent over hypotenuse. Yeah, you what? Okay, I'm coming.
What are those?
No.
No, I'll go
I'm gonna
mom.
have to come back for the tickets. Don't give you your stamp.
Put it down.
Who did I have here? I'll bring you your ticket. Israel, I had you. I'm bringing you your ticket. I'll be right back.
Yes.
But we look at your tickets. Tyler, I will be. Oh. And Sandy. You. And Yvonne, I'll bring you tickets too. Okay. Here we go. 5 people to share for me what you got, and when you say your answer, here's what I want. For example, if I was sharing the first one, I would not just say 8/17, I want you to say sine of theta is 8/17, so that you can practice saying them correctly. So first up, who can do cosine? Giselle.
Cosine of theta is equal to
Woohoo! Ding 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 ding. Next up, Diego.
Tangent of theta equals 8/15.
Lovely. Next up, Luis. Theta. Lovely. Next up, Juan.
Secant of theta is 17/150.
And last but not least, Kennedy.
Cotangent of theta is 15/8.
Right, cool. Okay, so we're just finding them, we're labeling them, we're good. Okay, now, a lot of the time, flip to the top of the next page, you will not be given a beautiful picture all labeled, okay? You'll be given some information, which is going to be enough for you to draw a labeled picture and find all of the trig functions. So if I tell you that cosine of theta is 2/5, and then I don't really give you a picture. I ended up giving you a triangle. You could have drawn your own, but I ended up giving you a triangle. But it's not labeled, right? I want you to use this as a tool because we're gonna practice a lot this unit, like drawing a picture to help us solve a problem. You're gonna try to label this triangle as much as you can right now to see what you know and see if you have enough information to find the rest that you need and then write all of your trig functions. Okay, so I'm gonna give you a minute right now to chat with your neighbors about what you know and see what you can label, and then we're going to come back and talk about it. 1 minute, talk to your neighbors. What do you know?
You know what I'm talking about.
Okay, what do we have 2 and 5, so I see Gustavo agree.
So then
Then he put 2 and 5 here.
that's not gonna be 2
Here, right, and here. Adjacent, hypotenuse.
That's a call.
Man, so many coffers.
We're all just gonna
Keep doing your work.
quick.
Sorry, my coughing.
So then this will be opposite, and then that'll be a
These were
adjacent.
beings. You all agree? Okay.
And
So,
then cosine
in order to do all
is-
these other ones, I like how Taylor said like some of the stuff labeled, but we're missing this one side. Do y'all remember how on a right triangle, if you have 2 sides, so you can find the other one? The a squared plus b squared equals c squared thing? Okay, so you can figure out that other side. Okay, let me see, what do we got labeled?
No, adjacent and
So you know that guy,
and then it's
and you know this side is
so then adjacent will be
opposite.
5.
Cosine is opposite
It'll be
over
2.
adjacent.
This will be 5. And this is 3. Let me see.
A over 8. Okay.
I
Okay.
feel like it's
Here we go. Let's share what we came up with, and then we'll finish off the problem. So, the cosine of 2/5. Who can help me out? What did y'all talk about? What does that help us get started on our triangle, Lirio?
cosine of theta is adjacent over hypotenuse, so 2 will be adjacent and 5 will be hypotenuse.
Cool. So the 2, if this is the picture you're using, 2 would go here, 5 would go here because it's adjacent over hypotenuse, like she said. Okay. From there, someone else. How does that help us? Like, what should I do next? If I need to write all of these 6 trig functions, what else do I have to figure out from my triangle here? No takers? This is what I have. I need to find out all these 6 trig functions. So, like, I go to do sine, and I'm like, oh, opposite over hypotenuse. And then I come over here, and I'm like, where's the opposite? How can I find it? Christina?
The thingy, like the 2x, and then one of them is the root of.
I see what you're talking about. We're going to see that in a second. The 2x thing that you're talking about is for a special right triangle when you have like either a 30, 60, 90 or a 45, 45, 90, that works. But we don't know theta right now, so we don't know if it's a 30, 60, 90 or a 45, 45, 90, so we can't use those, but that's a good thought. There's something else we know about right triangles, Brandon?
The Pythagoras theorem.
There you go. There's your Pythagorean theorem. Okay, what's that? Where's back up here? We gotta keep going. Gotta keep going. So, Pythagorean theorem says when I have two sides, I can always find the other one because a squared plus b squared always equals c squared. And I've got from this one side and then my hypotenuse. One of these specifically has to be your hypotenuse. Which one? C. So I know my 5 has to be squared over here. A and B could be either or, and so I can say that I have 2 squared plus b squared, and I just want to solve for the one that's missing, okay? So let's go ahead and solve this if you haven't already. I'm going to subtract, and I have b squared is 21. And then if I take the square root of both sides, b is root 21. Now be careful, remember when we take the square root of both sides, we usually have to be careful that we need a plus or minus root 21. Okay? Later on in the unit, when we get to like all 4 quadrants in the unit circle, you will have positives and negatives. For right now, let's pretend like we're building a fence in the shape of a triangle, and we're talking about like feet or something. The side of our triangle is just going to be some positive number. So let's just talk today about this is a positive root 21 right here, okay? Okay. Now that you have all 3 sides, if you haven't already, I want you to go ahead. I'm going to give you another minute while I pass out tickets to write down all 6 of these trig functions using those labels, okay? So you would take it there. Normally, I owe you a ticket. So you want to say anything? Christina, you just answered, right? I owe you a ticket. Good work. Who do I owe? I owe you just the ticket, or?
I'm just kidding, it doesn't work.
Okay. Anyone else? Hit it.
Don't hit the light.
What?
That's very left, right?
You can do it, Diego. There. He's so quiet. Okay, so we've got, I'm going to let you just check this time to speed us along. Root 21 over 5, 2 over 5, root 21 over 2. Okay, now I want to talk about the other side. We know that it's just be reciprocal, so for the first one, we've got, you probably wrote down 5 over root 21. Raise your hand if that's what you wrote. Okay, lots of people in here. Did anyone write it differently? Okay. For your final answer, so I know some people when we're checking, they're like, oh, and I got it, and then they're like, their brain shuts off, but stick with me. For this one, I would not want you to leave this as your final answer. Okay, we never leave a square root on a denominator. We have to do something called rationalize the denominator. Has anyone ever heard of this before? Not leaving the square root on the bottom? In the last class, they were all like, oh yeah, I'm gonna rationalize. No, you don't. Okay, that's okay. So we don't, in general, want to leave a square root on the bottom. So if this was like a multiple choice, you're not gonna see this answer probably in the choices. What they're gonna do is to get rid of that square root on the bottom, we need to multiply times root 21 over root 21, because on the bottom, if I multiply 2 of these square roots, I end up with root 21 squared, because I have 2 21s, and what happens with your square and your square root? They'll cancel out, and so we'll end up with just 21 on the bottom without a square root, and on the top, we'll have our 5 and our root 21. That's what we call rationalizing the denominator. Now there is no square root on the denominator. So I need you to write this answer in this form. not as just 5 over root 21. Y'all got that in the back?
Yeah.
5 root 21 over 21? Okay. For the next one, this one is just going to be 5 over 2. There's no rationalizing, so you should have that one. Okay. For the last one, you probably wrote 2 over root 21. However, we need to rationalize the denominator, so raise your hand if using my example, you can tell me what we should get as our final answer for this one. D'Anthea?
2 times root 21 over 21.
Great. So you can do them like in your head if you want. You don't have to write the multiplication, but you should end up with 2 root 21 over 21 instead of this form. Okay, yep.
So this is only when the number is rooted?
When the square root's on the bottom, because even here we were good. But if the square root's ever on the denominator. Okay, good question. All right, lovely. So we got those 3. Let's move on to when things get a little crazier, when we're solving for a side, and we are given an angle. Nearly there. Okay. We see the triangle. Let's just really quickly figure out what we know. It says find the value of x. So we want to find x, and we have some other information. What do y'all notice? What information do we have? Let me see some hands. What do you have? Lazaro. We know this time one of the angles, notice it doesn't say theta this time, it says 53 degrees. We literally have the degrees, okay? What else do we know? What else do we know? Drop it in. I didn't hear him.
Oh, there's a 90-degree angle?
There's a 90-degree angle. Cool. Okay. Other things? D'Anthea?
The opposite, right?
Yeah? What is it? Huh? 15? Okay, so the opposite, she says we know an opposite side, we know an angle, and then x, which is what we're trying to find, is what we would call what side? The hypotenuse. Sorry. I just let people off. Okay, so if we know the opposite, and we are trying to find the hypotenuse, I'm not even going to label my adjacent for right now because I don't even need to deal with that in this problem. Really quickly, looking at SOHCAHTOA, if I am dealing with my opposite and my hypotenuse, I want you to write down silently for me right now, 10 seconds, which trig function you think we're going to probably be using to solve. 10 seconds, I want you to write down which trig function, if we have the opposite and the hypotenuse, which trig function do you think we're going to be using? Alright, that was about 10 seconds to think. Melanie, which one do you think? Sine, do you all agree, has opposite and a hypotenuse? Did anyone have a different one? Kennedy?
I don't remember exactly how it goes, but when you use the angles that you already have, you can find the angle from the cross and get what you need because you don't already have.
Okay. Thanks for following you. Christina?
I think the cosecant, so you can get extra long.
So either one will work. Sine is opposite over hypotenuse, and cosecant is hypotenuse over opposite. So both of them deal with the O and the H, the opposite and the hypotenuse. So actually you could pick. I think a lot of people would pick sine just because they're more familiar with that, with SOHCAHTOA, and you might not remember cosecant off the top of your head, but you could actually use either of these, right? Okay. Could I use cosine? I like cosine.
No.
Why not? I don't have the adjacent side, right? Okay, so if I don't have the adjacent, then I'm kind of stuck. So I can't pick whichever one I want. I can't pick cosine, but I could use either of these two. Okay, so I've got the sine of, we'll just do sine since that was the first one y'all told me. Sine of my angle, instead of theta this time, I'm literally going to write 53 degrees equals my opposite, which is 15, over my hypotenuse, which is x, okay? And then we can just solve for x because all of these other things are numbers. So I can multiply times x on both sides. And then I can do what to solve for x and get rid of the sine of 53? Yeah, who was that? Divide. Divide by sine of 53 degrees. And I end up with x equals 15 divided by the sine of 53 degrees. So this is where our calculator comes in. We can actually find this decimal. Before we type it in, I want to make sure we're all in the right mode and teach you how to change the mode of the angle on your calculator. So if I could get everyone to grab their calculators for me, I'm going to check and make sure we all have it, and then we're going to change up the mode on our calculator. 10 seconds, grab your calculator, and then we're going to go to the main screen. 10, 9, 8, 7, 6, got it, to that home screen. 5, 4, 3, 2, 1. Okay, on the home screen, go to settings, number 5, settings. Go to 2, document settings, and you'll notice the second little option there says angle. Y'all see it? Okay. The angle could be in degrees or radians when you're looking at it. It's probably in one of those two if you're looking at it. We want it today to be in degrees because we want, when we type sine of 53, we want it to know that's 53 degrees, not 53 radians. So if yours says radians, I need you to change it. If yours says degrees, then you can leave it and then press make default, okay, and you should be good to go from there. Now notice, calculator's down for a second, because I know people are like, oh, 15 divided by sine of 53. Pause. In this unit, we are going to be dealing with radians and degrees once I teach you radians next week. There will not always be degrees. So part of the skill of this unit actually is going to be in a problem to recognize radians or degrees and like write it to the side. Because when you get to your calculator, you could on the test have to multiple times change the setting back and forth to calculate different things, okay? So make sure you know where I went in the menu right there, because those steps during a test, I can't, if you're like, oh my God, how do I change my setting again? You gotta make sure you know where to go to change it from radians to degrees and go back and forth. Today, we're not learning about radians, so they're all gonna be in degrees, so once you're in degrees, you should be good to go. Okay, pick your calculator up. Go ahead and type for me 15 divided by sine of 53. If you don't know where sine is, you gotta click this trig button right here and they all pop up. And you want 15 divided by sine, whoop, press the trig button of 53 degrees. 18.782. Okay, go ahead and try the next one, and then try the word problem if you have time, and I'll be walking around to check and catch up giving people things that they need. I want you to finish these two problems, and I also am technically not supposed to let y'all anymore in the first few months, and then so I can guarantee it. So you can finish those. Okay. Anyone else? How you doing? So figure out which one you're going to use for that one. No, you could find it because what's the total in a triangle? And you could find it, but you technically don't need it unless it asks us to solve for the other angle, and it only asks for that other side, so we only need one of these. Can I owe you one? That's why I'm standing by you.
Okay, this opposite, and then this right angle, so that's how better.
I bought it for trying to be better.
Today, because then one person gets the roll.
Bro, you didn't put it. Did you make
Thank you,
it?
I'm feeling really nice. How you doing, Brian? Big break? I know, thank you. I appreciate it. I'm really not.
Visit their website, it's like $5, just buy it, and then plug it in.
Anyone got it? Want me to look? 18. How'd you do it in your head? Oh, you did it in your calculator. You used tangent? What did you use? So you can't use the same one this time because oh, for this one you're good. Yeah, we went over that one. Go ahead and turn that. You're right. 18.72. Like here, look. Try the next one. Okay, anyone?
finished.
You got it?
Okay, good. Try that one.
Both of them?
Yeah.
Man, you're fast when you're over there.
Can I go?
Hold on, look. Good. Can you go put this one on the board for me? Wait, you didn't finish both? What? No! I thought that was fast. Huh? Can you go put that one on there for me? Oh, okay. Determine the length in feet that the runner must cover to reach the finish line. And huh?
I can only work on Saturdays and Sundays.
No, here, the X. You got it. Wonderful. Can you go put that on the board?
I have her as
Let me see. Did you change your mode?
No.
I had one, but last I tried to change someone, it was missing from my cart. Let me go look around again.
She had.
It's in radians.
You never said that.
Try it again. Boom.
I have it
Let me see. Yes.
right Oh, I did like to photo them. So I can remember exam.
Oh no,
No, but you said
Okay. All right, guys, back up here. Let's talk while Lazaro finishes. Okay, checking your work up here.
Lincoln with
For the second one, you will notice that Giselle used tangent. Can someone raise their hand and tell me why she used tangent rather than sine, like we used sine in the first example? Brandon?
This one we're looking for be adjacent and have the opposite. You don't have any of the
Cool. We got A and O, adjacent and opposite, so tangent is the one we need to help us. Can anyone think of one other option instead of tangent? The only other thing that we could have used would be what trig function? Diego? Cotangent. And I would actually argue, I kind of like, you might like the originals, but I kind of like using cotangent. Take a look really quickly. Because you would have x on the top, 9 on the bottom. What's the only thing you need to do to solve for x in this one? Multiply by 9. And if you type in this quickly to your calculator, you'll notice you get the same thing. But you could argue that's a little faster because the x is already on top. Okay? So it's worth like knowing that as a strategy rather than just always using sine, cosine, and tangent. But it's fine if you did that. Okay? Okay, and then the next one right here, we had Lazaro doing sine. Thank you very much. And he put 200 over x, solved for x, and got 224.465. And I love that he also included feet on his answer, because in this case, it was a word problem. So we want to make sure we put our units, and it's that length right there. The runner still has to run that many feet. Okay?
Okay.
Okay. Last thought. Before we get out of here, I'm going to kind of introduce to you a preview of what is to come with the unit circle. So if I can get you to look at this last section, we're very close to the weekend, so hang tight with me. Yes. Okay. Stick with me, we only got 4 minutes, I still want to talk about this. Okay. Kennedy, no, who was it? Christina?
Tyler.
Someone. I don't think it was it? Did Tyler mention the 2xx thing?
Yes.
Good boys.
Okay, anyways, eyes up here. The 30, 60, 90, 45, 45, 90 thing? Ish?
That was
No. So there are these things called special right triangles, okay, that we can only use when our angles are specifically 30, 60, 90 or 45, 45, 90. When that is true, we have this relationship between the sides, not just Pythagorean theorem. We know that if this is x, the hypotenuse is twice that, and this adjacent side to 30 is root 3 times x. For a 45, 45, 90, because it's isosceles, both of these two are the same, and this one is root 2 times whatever that side was, okay? So that might have been something that y'all learned in like geometry or something like that. We can use that to find the sine, cosine, and tangent of all of these sides. And then these are going to be ones that are really common that we're going to end up memorizing on the unit circle. Okay, so for example, this student already filled out a few of them, and there's some blank ones that you could figure out. I want, just in our last minute before I do raffle, us to think about why this student said that the sine of 30 degrees is equal to 1/2. So I want you to take 30 seconds really quickly. I want you to take a look at this triangle that has 30 degrees. I want you to think about why the sine is equal to 1/2, and I want you to write for me right here why you think the sine is equal to 1/2. I'm going to give out my last ticket and draw. You are writing why sine is equal to 1/2. Don't give up on me yet. All right. All right. Sine would be x over 2x. X over 2x, which simplifies to 1 over 2 or 1/2. No matter what those x's are, when one's on top and one's on bottom, they'll cancel. It's always going to be 1/2, no matter what those are, okay? So that's kind of like a mini preview to the unit circle. I'm sorry we had to rush through that, but we'll come up with that more later next week. Okay, raffle. Oh wait, why am I rolling the dice? That's not what I'm doing. Okay, winner is 351. There you go. Thank you. Bye, guys. Give me one. 353. Okay, roll.
5.
4.
Cookies.
Medal.
Come on, anything is crowd.
Yeah.
I need tickets.
That was just a test.
No, put my name in there.
Gold medal. What do you
No,
want?
me. Why?
What would you like? Is that what you said?
Why?
I know, what do you want?
Hi, Mel.
Yeah, that's it.
I hope I did so good, so I was like,
Oh man, I'm late.
Line?
Alright.
What's up, girl? Okay, that's fine. I was actually kind of wondering if I should tell you that I gotta get home too. So that just confirms that I probably should.